Hi, grade 12s. In this video, we're going to look at cubic functions as we start preparing for the upcoming final examinations. So in this picture, you can see a cubic function sketched, and which is very important for students to identify the cubic functions by looking at the equation and also by looking at the sketch. Let us read the description statement and check what we are given. It is very important for us to start by checking what we are given in the description statement. So it reads as follows. The sketch below represents the curve of f of x equals to x to the power 3 plus b x to the power 2 plus c times x plus a d. So this is the equation of the sketch below, or the equation of the curve. So that's what we're given. So this is in the form of f of x. The form of f of x equals to x cubed plus bx squared plus cx plus a d, right? Then the solutions of the equation f of x equals to 1 are -2, 1, and 4. So we've got the solutions of f of x equals to 0. So the solutions of f of x equals to 0, these are the x-intercepts. So the solutions that were given are the x-intercepts. Now, we need to calculate the values of b, c, and d. So when they say you calculate the values of b, c, and d, is the same as them asking you to determine the equation of the curve. So I want you to know this going to your final exam, that always when you are given, so if you are given x-intercepts, the convenient method of determining the equation of a curve is f of x equals to a times x minus x1 times x minus x2 times x minus x3, whereby x1, x2, and x3 are x-intercepts. So this method becomes convenient when you have to calculate the values of b, c, and d, or when you have to determine the equation of a cubic function when you're given the x-intercept. So after writing this form, which is the intercept method, all I need to do now is to substitute the values of the x-intercept in my x1, my x2, and my x3. So the value of a is given in the equation above because the value of a is the coefficient of the cubed variable. So the coefficient of x cubed is 1. So that becomes the value of a. So this is going to give us x minus x1. The first intercept is going to be minus 2 times x minus 1 times x minus 4. And then this is going to give us x plus 2 times x minus 1 times x minus 4. This will be the equation of f of x. So remember, our main goal now is to get the values of b, c, and d. So if we look at this function, it's a complete function, it's a complete equation, but it is not written in standard form. So for us to get the values of b, c, and d, we might write this equation in a standard form by simplifying it. So we might as well start by simplifying these two. So this is going to be x times x, going to get x squared, and then we've got x times minus 1, which is minus x, 2 times x, which is plus 2x. So minus x plus 2x is minus x. It's going to be plus x. Then 2 times minus 1 is going to give us minus 2. Then times x minus 4. And then this is going to give us the value of, so this is going to be x cubed, which is x times x. And then we've got x squared times minus 4. We're going to get minus 4x squared. And then we have got x times x. We're going to get x cubed squared. Then we've got x times minus 4, which is minus 4x. And then we have minus 2 times x, which is minus 2x. And then we've got minus 2 times minus 4. This is going to give us plus 8. Then therefore, f of x will be given by x cubed minus 4x squared plus x squared is going to give us minus 3x squared. So this is minus 3x squared. And then minus 4x minus 2x is going to give us minus 6x plus 8. So therefore, from these two values, or from these equation, we can tell that the value of b, therefore b will be equals to the coefficient of x, which is the coefficient of x squared, which is going to be minus 3. And then c is going to be the coefficient of x, which is going to be minus 6. And then d is going to be the constant, which is going to be 8. So that's how we can get the equation of a cubic function if you are given the x-intercept. Okay, so now we have the equation of the cubic function given by x cubed minus 3x squared minus 6x plus 8. Now, we'll need to try to answer the question that follows, which is 9.2. So 9.2, they want us to calculate the x coordinate of B, the maximum turning point of F. So we need to calculate the coordinate of B, which by identity is the turning point of F. So guys, every time you see the word turning point in differential calculus, what must come to your mind is that at the turning point, the first derivative is equals to 0. So this is a fact that is going to assist you to calculate any coordinate of the turning point. So let's try to calculate the coordinate of B. So we're going to use the fact that the first derivative x is equals to 0. And all we need to do now is to derive f. Then this is going to give us 3x squared minus 6x minus 6. And then the derivative of 8 is 0. This is going to be equals to 0. All we're trying to do here, we're trying to solve for x. And then now this is the same as x squared. So you're going to divide throughout by 3. This is going to give us x squared minus 2x minus 2 equals to 0. And now we need to solve for x here. So the value of x that we can get, we can try to use the quadratic formula, which is the very simple to answer this one. So you don't have to factorize or write it in its simplest form for you to use the quadratic formula. You can also use the quadratic formula when you are still working with 3x squared minus 6x minus 6. So those that take out the common factors or divide throughout by 3, it's going to work for those that wish to use factorization if your expression can be factorized. So if you don't want to make any mistakes, when solving for a quadratic equation, go with the quadratic formula, and that will give you the answers right away. So this is going to be equals to x equals to minus the value of b here is minus 6 plus or minus, which is minus 6 squared to minus 4 times a. The a is 3, and then times minus 6, which is the value of c, divided by 2a, which is 2 times 3. And then that will give you two values of x, the first value, L, the second value. And then you press your calculator to get those two values. So the first value of x that we get is 2,73. Then the second value of x is equals to minus 0,73. So between these two values, the negative and the positive value, the one that is fit to be the x coordinate of b is the negative 0,73. So the x coordinate of b will become negative 0,73 because the position of b in the graph lies on the negative x-axis. So that's how we can determine the value of the x coordinate of b. Then 9.3, you say you determine an equation for the tangent to the graph of f at x equals to minus 1. So now what they're saying to you is that the graph has got a tangent at x equals to minus 1. So to answer this question, guys, it's very simple, because when you need to determine the equation of a tangent, which is a straight line. So we don't have to forget that a tangent is a straight line. So whatever that we're going to calculate or whatever that we're going to determine will be in the form of y equals mx plus c. So all we need to get the equation of a tangent, we need to know the gradient of the tangent, right? And then we also need to know the point of contact. So we're given the point of contact, which is x equals to minus 1. We have got the x value of the point of contact. So always you must make sure that you've got both the x and the y value of the point of contact. So we're going to use the equation of the curve to get the y value of the point of contact, and then we're going to substitute x. We're going to substitute minus 1 to x. This is going to be f to the power negative 1 equals to minus 1 cubed minus 3 times minus 1 squared minus 6 times minus 1 plus an 8. And this is going to give us the y value for the point of contact. So when we press our calculators, we're going to get minus 1 squared minus 6 times minus 1 plus an 8. Then we're going to get 10. So we're getting 10 for the y value. So therefore, the point of contact is going to be minus 1 is to 10. So at this point, that is where the tangent is in contact with the curve. So from there, we need to know the gradient of the tangent. So we know that at the point of contact, the gradient of the curve and the gradient of the tangent are equal. So therefore, we need to get the gradient of the curve at the point of contact. So the gradient of the curve, which is the first derivative, we know the first derivative is the gradient of the curve at any point, which is 3x squared minus 6x minus 6. So this is the gradient of the curve at any point. Now we're interested in the gradient of the curve at x equals to minus 1. So we want to know what will be the gradient of the curve at x equals to minus 1. So we're going to substitute x equals to minus 1 to the gradient of the curve at any point. And that is going to give us an answer of 3. So this is going to be 3 times minus 1 squared minus 6 times minus 1 minus a 6, and then this is going to give us a 3. So therefore, this means that the gradient of the curve at x equals to minus 1 is 3. So if this is the gradient of the curve at x equals to minus 1, therefore it means that this becomes the gradient of the tangent. And the reason why it is becoming the gradient of the tangent is because the tangent and the curve at x equals to minus 1, they've got equal gradients. So now you have the gradient of the tangent. And now if you have the gradient of the tangent, you can get the equation by simply using y minus y1 equals to mx minus x1, or other methods of determining the equation of a straight line that can be convenient to you. So this, we're going to take the point of contact, we substitute it to y1 and x1. So this is going to be y minus 10 equals to 3, where there's gradient, x minus minus 1 is going to be minus 1 there, and then that's a plus 1 we know. So this is going to be y minus 10 equals to 3x, right? 3 times x is 3x, and then this is 3 times 1, which is going to be plus 3, and then therefore the simplified will be equals to y equals to 3x plus a 13. And that will be the equation of the tangent to f at x equals to minus 1. Thank you. I hope you enjoyed, and I hope you have benefited a lot from one of the methods of determining the equation of a cubic function. Stay tuned for more videos. Don't forget to like, share the videos with your friends, and most importantly, don't forget to subscribe. Thank you.